Good afternoon, everyone. We'll be getting started in just a minute or two. Okay, let's go ahead and get started. Thank you, everyone, for joining us today. My name is Sean Maurer with the Smart Energy Design Assistance Center. I'm joined today by my colleague Ryan Siegel. We will be discussing commercial site inspection, key items to look for. Before we get started, just some housekeeping notes. If you need to ask us a question during the presentation, please be sure to enter that into the question and answer pane. If you hover over the bottom of your screen, you should see that pop up near the center. May also appear near the top of your screen. If you enter questions into the chat window, we may not see those, but we will definitely get notified of them in that Q&A pane, so please use that to ask questions of us. Today's presentation is being recorded and will be available on our website after the presentation, along with a PDF of the slide deck. If you need IECC or AIA continuing education credits, please let us know after this presentation. We will send out an email with a certificate of participation. If you need those continuing education credits, reply to that email with your member number, and we'll get back to you and turn those credits in for you. So what we're going to cover today, understanding commercial energy code site inspection practices, learning which measures are generally not meeting the code during the construction phase, and demonstrate how to comply with the energy code requirements during site inspections. The Smart Energy Design Assistance Center is an applied research program at the University of Illinois, and our mission is to reduce the energy footprint of Illinois and beyond. And this is one of the many programs that we house here to achieve that goal. We want to thank the Illinois Environmental Protection Agency's State Energy Office for helping fund this presentation. They're a wonderful partner for us, and we want to make sure that they get due credit for helping us produce these programs. If you need to reach out to us with a technical question, we do provide technical support services. You can email us at energycode@sedac.org or call our hotline at 800-214-7954. We also have many resources available at our website, sedac.org/energy-code. All our past workshops used to be held on site, but we recorded those on audio and provide the slide decks. And our current workshops, which are all been held on Zoom, are available on our website. Past webinars. We also have online training modules that are available. They are self-paced training modules, but they're designed to be introductory level, so easy for homeowners, building owners, code officials, architects, designers, engineers. Anyone can look at those and get familiar with the energy code. They are designed to take about an hour to an hour and a half to complete, and you do get a certificate of completion once you've completed those courses as well. And we also have links to our technical support information that was listed on the previous slide. We also have links to the IECC energy conservation codes, the Illinois amendments to those codes, and the Chicago Energy Code, along with frequently asked questions and other useful websites. So these are the links to those codes. one thing we'd like to note about the IECC's code website, on top of having the most current version of the IECC available to view for free, they also have the Chicago Energy Code listed there now, and it does have a robust search function. So we often go there ourselves when we're looking up questions to quickly find the information that we need, and then may dig into more detail with paper copies. We also have a link to the Illinois amendments, so you don't have to remember those long URL codes. You can just go to our website, click on the link, and it'll take you straight there. Just a listing of our upcoming series of workshops. We've been doing a series this program year covering improving code compliance. So we've covered residential and commercial site inspections and plan reviews in this series. And you can see the upcoming dates for our next workshops here. We will also be hosting code panel discussions. Those will be an excellent opportunity for designers and code officials to come together and have a useful discussion on where energy code issues may be and how to address those. We're very much looking forward to hosting that panel discussion. We also host a series of lunchtime webinars, last for about an hour. Our next webinar will be in February. It's going to be a case study or lessons learned for the energy code compliance process. And then we'll be covering commercial lighting, commercial HVAC compliance in March and May. So when does the energy code apply? That's the first thing we're going to cover. In general, the energy code is triggered when a permit is required for work at a site. So if you have to apply for a building permit, then the energy code is going to be triggered. We've listed here some exceptions from the 2015 International Building Code that are examples of things that are typically exempt from having to have a building permit. But this does vary slightly from location to location with different municipalities. So this may not be a comprehensive list for your local area. Please contact your local building office to make sure any project that you're starting, whether it requires a permit or not. So today, as we're covering commercial buildings, it helps to know what is a commercial building. The Energy Conservation Code describes a residential building as a detached one-family or two-family dwelling, or any building that is 3 stories or less above grade, 4 stories in Chicago with their amendments, that contains multiple dwelling units in which the occupants reside on a primarily permanent basis. So this would exclude hotels and motels, but would include townhouses, row houses, apartments, single-family homes, monasteries, and other such facilities where people stay on a semi-permanent basis. If it's not a residential building, then it's a commercial building. So if it doesn't fall in one of those examples or under that definition for residential building, then you have a commercial building site. And I will hand it over to Ryan to dig into our first section, going over commercial building envelope site inspections.
Well, thank you, Sean. So we're going to start, and as Sean noted, the energy code kind of just breaks buildings into 2 classifications, either residential or commercial. So things that we think of is commercial, industrial, government, all of that falls into commercial. So so starting with the footings and foundations and working our way up. First, starting with our what we're needing to cover as we're going out to do the site inspection, and understanding that inspections occur many times for things other than the energy code as well. The building codes have many inspections, so some of these may occur during other site inspections for building code compliance and the like. So with that, we're going to be checking several different things. First up, looking at our R value. Is our insulation in the right location? Is it the proper thickness? Do we have it buried appropriately, and is the insulation protected from physical damage or other damage. So this also may be fire protection for insulation depending on the type. So many different aspects that we need to be looking at as part of our inspection. One thing that is very helpful is the ComCheck actually does a very nice job as far as depicting what the various definitions are. So looking at what is a wall height, how far is the depth below grade, and understanding where those different points start and stop. You can see that the depth below grade starts from the grade level and then goes down to the top, the finished floor level there. So, helping with some of these, getting a good illustration of some of these definitions. So also noting here that the rim plate is not part of the wall. That is actually part of the floor above. And here noting that the ComCheck, as you're going through, frequently does make several assumptions. And so being aware of what these are and correcting these assumptions to apply best for your actual design. Actually just had a question this morning on this exact thing, as far as making sure that the what is entered into ComCheck is reflective of the actual design and the field installation. We always hope that the field installation matches the design and matches the ComCheck, but it doesn't always. And so making sure that we're verifying that as we go through. So as far as our insulation and the location therein, so again, we're looking at footings and foundations. So looking at, are we looking at interior insulation versus exterior? On the left here, that appears to be an external continuous insulation that is installed there. And on the right-hand side is a cavity insulation installed on the interior of the wall. And so making sure, again, checking, do we have this in the location and the type of insulation, cavity versus continuous, as was specified. So something to be aware of is the definition of continuous or cavity insulation. Cavity insulation is insulation that is installed between between framing members, whereas continuous insulation is only broken by the fasteners or service openings. So we can see a couple of different depictions here. On the left-hand side is some continuous insulation that has some metal furring strips attached on the face of that and through the face of that insulation. The next one down is a continuous applied directly to, looks to appear to be CMU or something of that like. And then further down is insulation that is installed between metal furring strips. So in the top, because that furring strip is applied to the surface of the insulation and the insulation is not broken by that furring strip, that would be continuous, as would the face applied. That lower example, metal furring with insulation between, that would be cavity insulation. So this may also look like Z channels instead of just continuous furring strips. This could even be Z channel. So that could, if you have Z channel that is interrupting that insulation, that would also cause this insulation that may be a sheet good to not be continuous insulation. So making sure that we're maintaining that continuity and eliminating or minimizing any thermal bridging that we can. So again, the thermal bridging through continuous insulation is just service openings and fasteners only. So next thing is we're checking our insulation, is verifying what is the R value. You know, how much is there, and does it match the design? You know, here on the left, we see that this is on the label here. It says it's an R19 batt insulation product for 2x6 walls, and the label also notes here that it's 6¼ inches thick. As practitioners understand, a 2x6 is really that is the nominal dimensions of the lumber. That is not the actual dimensions. 2x6 is typically along the lines of 1.5 inches to by 5.5 inches. So if you take this 6.5 or 6¼ inch thick batt and place it into the 2x6 wall that's 5.5 inches in cavity, that R19 is actually decreased down to an R18. So it may be such that what is printed on the face of the batt may not be the correct value as it is installed. So just being aware of that, and where we do have compression of insulation, that can diminish the performance. So similarly here again, you know, if the COM check says this is an R19, that would be an incorrect COM check, because as it's installed, it's only an R18. So again, being aware of that. Foam and sheet good products tend to have a little less issue with this. However, sealing between panels becomes very important for sheet goods. So here it's stating its R value again at a given thickness. So things that we might be looking for is the insulation compressed, and does it fully fill the cavity? Here on the left-hand side, we can see here's a cavity. These are metal studs with a batt product placed inside of them, and we're seeing a lot of the metal studs being exposed here. Not only at the top, but here in the middle. So there is a lot of compression going on. Looks like maybe some of this has to do with the insulation batt not being split and run around pipes and wires. And so that can cause the insulation to degrade in performance. Something else that we're noting here is, because this is a metal wall, or metal framed wall, one common issue that we run into following occupancy is what we show here on the right, which is ghosting that appears on the walls. So this is where that stud is not thermally broken and allows that heat transfer, in particular cold, to transfer through during the winter. And so you may have the warm moist air on the interior, and that moisture is attracted and potentially condensing onto that wall, and allows dirt and dust to adhere to that wall. And so this is something that, if you see, this is typically due to not having any continuous insulation or a non-thermally broken wall assembly. So it is perfectly possible to have a code compliant installation that has this issue and this problem. So just being aware and trying to look to build better designs as we can. Getting into our footing and foundations for exterior insulation, does it have the proper depth? Depending on where you are, this could be required to go down, this insulation could be required to go down 2 foot below the grade, 4 foot, 10 foot. or 6 inches short of the floor, depending on where this is, and understanding that part of this could be horizontal. So on the right-hand side, we're depicting insulation that has both a vertical component and a horizontal component. So we have run into instances, particularly for perhaps a renovation, where trying to dig down 2 foot down all the way around a foundation can be very difficult. But what may be much easier to do is to dig down 12 inches wide and dig down 12 inches deep. So that would allow me to get 1 foot vertical plus 1 foot horizontal to give me my 2 foot of depth and 2 foot of distance without having to dig down the full 2 feet. So there are some practical benefits to enabling this horizontal. One aspect of this horizontal is if you are using the earth as part of your physical protection, the code does require that the earth be at least 10 inches thick. So I couldn't have this insulation stop just shortly below grade and then go horizontally. It has to go down at least 10 inches below the finished grade if I'm using dirt as that form of protection. Also noting with this protection and making sure that we are not only protected it against potential compression and physical damage, but also understanding that insulation may be degraded through ultraviolet or pose a potential fire hazard. So making sure that we are protecting our insulation against our physical damage, compression, ultraviolet, and fire. Some new products are continue to come to the market to provide some of these in a single product rather than necessarily having to install some additional protection after you install your insulation. So, and here noting that 10 inches again that I had mentioned earlier. So with that, we've made it through our footings and foundations. So now we're going to move up to our thermal envelopes. So this is including our walls, our roofing, our fenestration, and the like. So with our thermal envelope, it's not uncommon where we see that this inspection is broken into 2 different stages. As I noted earlier, buildings, it's not uncommon for them to see many inspections. 10 or 20 inspections would not be that uncommon. So this may be done in stages and phases during some of those inspections. If it is done in 2 parts, which may also be a very beneficial and perhaps a good practice, breaking this up into our framing and structural and our air sealing as one inspection, and then the insulation inspection being done at a separate time. So one concern that does come into play, if you are doing this as a single thermal envelope inspection, this can be much more difficult to verify because insulation will cover many potential air leakage sites, be it cavity bays, rim joists, and so several of these areas may be very difficult to air seal. And so if you, it's not uncommon that these go unseen because an air barrier test was never done on most commercial buildings. So. Again, similar to the footings and foundations, we're looking for many different aspects of the insulation and air sealing details for the thermal envelope. Here we see a metal building where they're going ahead and putting some spray foam insulation. This spray foam insulation If it's closed cell, and at least 1.5 inches can be a nice air barrier. If it's open cell, it does need to be thicker. It's not uncommon where, depending on the product and the manufacturer, may require anywhere from 4.5 to 6.5 inches of open cell spray foam insulation to be that proper barrier for you. So, but can be very effective. And also air sealing through tapes and other membrane products too. So things that we're checking for is types of insulation. It's again, not uncommon where you may end up with different products in different locations. So exterior, you may end up with insulated metal panels on an exterior and a batt product on the interior, or a rock wool on the roof, or something of the like. So checking, what type of insulation do we have in the different locations, and again, do we match the design? That's through and through. Most all of this we're verifying is, does this actually match what was in the design that the plans that the plan reviewer inspected and verified that yes, that's acceptable. So if it is different from the design, this could be a major issue if the insulation was designed to be the vapor barrier. The vapor barrier is not addressed as part of the energy code. That is found in your building codes. But if your exterior or interior insulation was designed to be the vapor barrier, and they used a different type of insulation, and that's no longer the vapor barrier, you may have a missing vapor barrier completely. So that's definitely something to key in on, is if the insulations don't match and the original insulation is supposed to be the vapor barrier, or conversely, if it was not supposed to be a vapor barrier and then it was changed to an insulation material that is a vapor barrier, you could potentially have a double vapor barrier. Having two vapor retarders is not a problem for an assembly, but you do not want two vapor barriers in an assembly, because you can end up with moisture trapped between those two that can't leave. So other things checking for is the R value doesn't match the design. If if you do have projects that do have blown in insulation, do you have the proper depth gauges for that? A little less common that we see this in commercial, but this could certainly be found for neighborhood commercial, small banks and restaurants and things like that. So your neighborhood commercial may have this. One thing that we are depicting here, if you do have this, is making sure that the markers and gauges were installed correctly. Here we show where a depth gauge here is showing that insulation at a particular depth would be 18 inches, but using a tape measure, it was found that that would actually only be 15 inches. So this gauge is actually slouched by almost three whole inches, which could dramatically change the performance of the building and the comfort of the occupants therein. So, similar to the walls for our roofs, checking do we have it in the proper locations. Some designs may call for it to be up against the attic or the roof. Some may call for it on the floor of the attic or the above the ceiling. So checking to make sure again that we have the proper location, and again, is it continuous versus cavity insulation? So probably more common in commercial might be using insulated metal panels, or if you have low sloped roofs, the insulation being applied directly on top of the roof sheathing. So, Again, if we do have BAT products and other things, are we checking for proper installation? Again, we don't want gaps or compression because that's diminishing the expected performance. If I were to have to choose between these two, compression is typically easier to remedy than not being filled. Also, not being filled, that can be a dramatic difference on the performance of the building. So fenestration is another big area. And so making sure that we're checking for the various aspects that are called for in the labeling and our air leakage controls. Do we have our proper air sealing between the window and the wall? Or similarly, a skylight and a roof. If that air barrier is not maintained, again, you have moisture and humidity that can be moving through that assembly and condensing, causing issues, not to mention comfort. So first starting with our U factor. So for small projects, this is generally not uncommon to see these applied directly to the windows. For site-built fenestration, these have to be separately rated, and this sticker would not necessarily be applied to the window, but this would be a printout report and a printed out label supplied to the code official as for the inspection. So making sure that we do have our U factor and again that it complies with the code required and more specifically, does it match the original design? So after the U factor or the transmittance factor, looking at the solar heat gain coefficient, depending on where you are, this may or may not be applicable for your area, but just making sure that it matches the design because as buildings are getting better and better, part of the aspect is we are looking to it's not uncommon where we are now looking to take advantage of that solar heat gain to assist in the heating of buildings rather than just relying on the building heat, the heating system alone. So taking advantage of that solar heat gain when it's beneficial and not when it's to our detriment. So additionally, we're going to look at visible transmittance. And also important to us is our air leakage rate. Air leakage rate of 0.2 is the maximum that is allowed here by the energy code. And again, looking at and understanding that air leakage is a dramatic driver of thermal performance of a building. And so part of that function is making sure that our fenestration doesn't leak too much either. So again, a 0.2 is the maximum allowed for air leakage. So all four of these aspects are important as part of your NFRC labeling and inspection. So U factor, solar heat gain, visible transmittance, and air leakage, all critical. So using good products but installing them poorly is unfortunately it does not work very well. That's something that we find common in assessments that we do of buildings. Is it is not uncommon to find newer buildings performing less well than older buildings, and some of this goes back to details and proper installation of materials. So as we're looking at our fenestration, making sure that we do have our proper installation. Installation of fenestration is one of those things that has changed here. As far as best practices, we've learned much more about building science over the years, and so best practices for installation have changed here in the last couple of decades. So making sure that one of the primary things now is looking for a double seal. So our exterior seal is predominantly for bulk water, trying to keep bulk water out of the assembly and out of our building, and then an inner seal that is used for moisture and air. So our vapor and air barrier is seal is to the inside of the frame, and then our bulk water being on the exterior. And where that comes important is making sure that the bottom flange, when you use this double sealing technique, is making sure that the bottom flange is not caulked, so any bulk water that does enter that pressure moderated space has a way to get out of the assembly, and we want to make sure that that drains to the exterior and not get into our building. So the air seal and vapor seal is going to go on all four sides of our fenestration, whereas our bulk water is just going to go on the sides and the top. So here again, here's another depiction calling out here. Here again, you see the double seal. So you have our bulk water seal to the exterior, and then our air and vapor seal to the interior. And so that pressure, the pressure, because this space is open to the outside, the pressure across this bulk water seal is going to be nearly equal. And so that's going to make this seal have to work substantially less hard to keep the bulk water out. This is also the seal that's going to be exposed, and so is likely to see most of the harsh environment, where the inner seal, that's our air and vapor seal, because it is inside the assembly, is going to be able to maintain its integrity for a much longer period of time, and is less likely to be damaged. So again, making sure that we build it right, and understanding that we want to make sure that this is durable for the life the life of the fenestration and wall assembly if we can. So something else that we're going to be checking for as part of our thermal envelope is our fenestration air leakage controls. Were the windows installed such that they're square to the frames so that they can close all the way and seal? If locks are unable to engage properly, that's a likely indication that the fenestration was not installed squarely in the opening. And again, it's not uncommon where the windows and that air leakage rating is relying on those window locks to engage and pull the window together. Also see that window gaskets and window seals may have not been installed fully. And so if a building does a pressure test, this can be something that can be identified or typically observed much more quickly than if we rely on just time to do that for us. So again, checking for our air leakage, do we have the joints sealed? Here we're showing a building that's appears to be using a building wrap product. This can be very difficult to install properly. It can be great until you start putting fasteners in it to hold it to the wall. So building wraps are definitely something that we don't like to see as much as perhaps a fully adhered membrane, because again, all those fasteners that have to be installed to hold that membrane, all of those fasteners are now points that this can leak over time. So, and checking for any joints around dissimilar metals, making sure, do we have, is whatever sealing method flexible enough such that when these surfaces move at different rates for expansion and contraction, that joint doesn't pull apart and pull open on it. So, making sure that dissimilar metal or dissimilar materials in particular, making sure that we're not using a hardened product, and similarly, not uncommon to see where people who are not as well versed in material science may see a gap and just apply oodles and oodles of caulk to that and really build that up thick. The problem is when you end up with a thick block of caulking, it loses its elasticity. And so making sure that we're using the backer rod such that we end up with that nice elastomeric sealant that's able to be flexible. So with that, I believe we have a poll question coming up here, looking at our thermal envelope and our foundation insulation. So first, noting, asking, can sheet insulation installed with full Z channels be considered continuous insulation? Yes or no? And second, which of the following components need to be on the NFRC label? This is multiple choice, so choose all that apply. U factor, solar heat gain coefficient, visible transmittance, air leakage rate, and comfort rating. Again, if you do have any questions that come to mind during the session, please go ahead and use that Q&A panel, and we will look to answer them either during the presentation or at the end.
Give it a couple more seconds here as we're still getting a few respondents coming in. Okay, it looks like everyone's. We'll share those results.
Okay, so can sheet insulation installed with Z channels be considered continuous insulation? This was a little bit of a tricky one. Z channels, in order to meet the definition of continuous insulation, it can only be bridged by service openings and fasteners. Z channel would actually create a second cavity, so that would no longer be continuous insulation. And which of the following needs to be on the NFRC label? Most everyone got this, all of them except for the comfort rating. So comfort rating is not actually an aspect of rating of windows. It is a result. It is commonly a result of fenestration, but it's not an actual rating. So with that, I'm going to turn it over to my colleague Sean for plumbing and mechanical.
All right, thank you, Ryan. So the first thing we'll look at is plumbing inspections and the hot water systems. So what we're going to be looking for, the types of insulation, do those match the design and the required R values? Is it properly protected? Any required controls are in place and properly located? And are heat traps installed on storage tanks for hot water systems? So for types of insulation, I think most people are familiar with the different types that are out there. You've got fiberglass wraps with the all-purpose or the weatherproof wraps that go around them. You've got preformed elbows and fitting insulation wraps. You've also got blanket wraps that strap on around those fittings, and you've got this kind of EPDM foam that just wraps around and seals to itself. That's fairly common for smaller lines such as refrigeration lines and small service water line that require insulation. Something to be aware of is that your insulation meets the required R value. So we're showing here in a table for various wall insulation thicknesses of these pipes. You've got different R values per the energy code. For hot water insulation, it must be a minimum R3 insulation value on that insulation. So noting here that this 3/8 inch wall would not meet that minimum code requirement. It has to be a 1/2 inch wall or thicker for service hot water lines. Um, for steam lines and chilled water lines, those insulation values are in mechanical um, design manuals, will be thicker. You'll see things more like fiberglass insulation on those with a protective wrap, and not so much these foam sealants or foam insulation. So for protection of that insulation piping, one thing to be aware of is that it cannot be an adhesive covering. It must be something that's removable, so that insulation can be removed for maintenance purposes, reinstalled, and then that protective coating put back in place. A lot of these PVC wraps, these all-purpose wraps for inside buildings, can be removed, are generally held in place and closed with some kind of tape sealant that can be cut off, the wrap removed, and then placed back around fittings and joints. Um, so both of these would be in compliance with that code requirement. Another thing to be aware of is that insulation is outdoors. You must have a UV protection for it, as well as weather, mechanical, and maintenance protection for that insulation. Um, for smaller foam installations that are used on refrigeration lines, it's not uncommon to see a painted on UV coating. Um, just to be aware that that coating does need to be maintained every 1 or 2 years, needs to be reapplied to maintain its protective properties, and making sure that some documentation has been provided to the owner that they know that that needs to happen. As far as plumbing system controls, making sure that they are required, the mechanical or the service water codes, if you've got circulation systems, both require that they're whether you're using a recirculating system or a continuous circulation system, that there be a demand requirement for that hot water circulating pump. It should not run 24/7 anymore. And you cannot use a timer-based control system. It has to be demand-based. Um, for a dedicated return circulation loop, where the hot water system has its own dedicated circulating loop, the most common place to see that control setup is a flow meter installed on the cold water tap coming into the hot water tank. As that tank needs to refill, as hot water is drawn out, then that flow meter will indicate that there's been a demand, and that circulating pump will then kick on. And should kick off once the circulating loop has met its set point temperature again. For a demand recirculation loop, you may have different sensors in a restroom or kitchen, wherever your hot water service is being supplied to. It could be as simple as a low voltage push button, or you could have an occupancy sensor in, say, a restroom. Someone's walked in, there's going to be a hot water demand. Go ahead and start that circulation pump up and make sure that hot water is readily available for the occupant in that restroom. So there's different ways to achieve that demand requirement for the codes, but no longer can you just have a continuously running circulation system. There is that demand component that we want to make sure is properly installed and is set up to work as specified in the design drawings. And for hot water storage tanks, you do need to have heat traps installed. The picture on the left here is what those might look like before they're actually attached to the system. On the right, you see a different method where you've got kind of a heat trap loop. As hot water tries to rise through that loop, cold water has settled in the bottom end and prevents water from circulating out under natural convective forces through hot water buoyancy. So we're just looking to minimize that heat loss coming out of those storage tanks from natural circulation loops. Moving on to mechanical systems, there's a lot of things that need to be checked here just because the energy codes have continued to add more and more automation to the buildings to try to achieve higher and higher efficiencies with mechanical systems. So during the site inspection, you're going to be verifying that the equipment type matches the design, the size, capacity of that system matches the design, the efficiencies match the minimum requirements or better. Um, Required controls are in place as far as temperature control, setbacks, demand control, ventilation, energy recovery, economizing controls, fault detection and diagnostics if those are required for certain economizer systems. And then you're also going to be checking for the proper insulation value on duct systems, that duct systems have been sealed appropriately where required. Um, Air dampers have been properly installed, functioning properly, and achieve the air tightness that they are designed for. Um, Minimum fan efficiencies have been maintained. So there's a lot to look for in this section. Um, One of the easiest ways to probably coordinate verifying all this information is to work with a commissioning contractor. As the code official, you can inspect capacities for systems and system types, things on site. Um, but the commissioning process, making sure all the controls on these systems are working properly, um, needs to involve a commissioning agent or someone with the firm that's doing commissioning and making sure that these systems are working properly. The code official may want to, for a site inspection, verify that the initial commissioning report is being, you know, while these systems are being brought online, that they're filling out that initial commissioning report. Um, that commissioning report is going to denote any initial deficiencies where things aren't working as they were designed to. A sensor was installed that isn't wired up properly or something like that. Um, so when a code official comes out to do their site inspection and look at these systems, they may also want to ask for some documentation that initial commissioning report is also being conducted while these systems are being brought online. And depends on what stage of the site inspection process you're in, what you're going to be looking for. Early in that process, you're just going to be looking for the commissioning plan, before things are actually up and running. It's just that there's a plan on site for how to check for those things. Once things are installed and they're working and you're getting towards your final inspections for the facility, now you're looking for, was that initial commissioning plan completed? Was there a plan for how to address the deficiencies? And are those deficiencies now being corrected as the building is getting close to handover to the building owner? One thing to be aware of with air conditioners versus heat pumps, if you do have heat pumps installed in the building, there is that additional commissioning requirement to make sure that the reversing valve is working properly for that heat pump to function as it should. If you've got electric heat versus gas backup, again, electric heat's a fairly simple process, on-off control or rheostat modulating control for that heat. It's fairly straightforward, where gas systems, especially if you've got hot water systems being heated by gas, you've got a little more complex control as far as the circulation loop, modulation of the boilers, and capacity control of those systems as far as staging of the units and modulating of their firing rate. Um, so some things to be aware of when looking at mechanical systems as far as commissioning and proper function during site inspections. Does it match the design? Does it match the com check? If you got an initial com check report for the design of the building that verified it was going to meet compliance with the code, then you've got that initial com check report that contains this detailed listing, an example of which we have at the bottom of the screen here. The first air handling system is supposed to have a hot water capacity of that 219 kBtu per hour. Does the actual installed system have that heating capacity or not? Same thing for the cooling capacity, the listed efficiency for the cooling system. Is it even serving the same space as it was noted in that com check? So these are things to kind of be looking for and comparing against while doing those site inspections. Again, really just going back to, does what's installed at the site match what was originally designed for the building? And if there was a significant change, was that change documented and then re-verified to be in compliance with the codes? Equipment controls that need to be verified, ventilation controls and temperature controls. So again, going back to damper air sealing, are those dampers going to meet their Air leakage requirements, are they properly closing? Do they have full range of motion? Temperature controls, building automation systems, things like that. Are those all in place? Are they working properly? Is there a commissioning plan in place to verify that function? And is it being acted on? Duct insulation, where outside the thermal envelope, where you've got ductwork in conditioned or unconditioned spaces, is it properly insulated? Um, Probably not as common to see ductwork in unconditioned space in commercial buildings, but you do often have ductwork run across rooftops in some situations, particularly I've seen on lab buildings and hospitals. You tend to have some portion of the ductwork outside the envelope. Something to be aware of is if you've got ductwork above a drop tile ceiling, that ductwork is technically within a conditioned space. Drop tile ceiling plenum spaces are indirectly conditioned by the spaces that they sit above. So that ductwork is not required to have insulation, although we do recommend for designers that they include some there just as a protection against condensation should there be an envelope issue that allows moisture into that space. Since it's not being directly conditioned, it is more likely to develop humidity issues and then develop condensation on the ductwork. Next is checking the insulation R values for commercial buildings. If it's outside conditioned space, does it have that proper insulation values for the area it's located? If it's outside the building, is it that R6, R8 insulation at a minimum? And also verifying, is that ductwork properly sealed underneath? So for most systems, you're going to have duct sealing completed. The only places in commercial buildings that are not required to have duct sealants are on ductwork designed for less than an inch of water column of pressure. Those transverse joints, as long as they are not snap lock or button lock joints, are not required to be sealed with mastic or tape. But as soon as you get into a system with greater than 2 inches of pressure design, which is going to be most of your distribution ductwork, that ductwork does need to be sealed with mastics throughout. The only place where you're going to typically see the ductwork with less than an inch of water column design is going to be after VAV boxes in most situations. For ductwork designed for greater than 3 inches of water column air pressure, static pressure in the system, those do need to be pressure tested per the SMACNA manuals. There are prescriptive duct leakage requirements for high pressure duct systems, which is typically going to apply to ductwork that's right against the air handler. As you can have pressures exceeding 3 inches at ductwork immediately after the fan system. As far as HVAC fan efficiency, again, going back to a ComCheck report or design documentation, looking at, did the initial fan system pass as far as the, was it under the nameplate motor horsepower or brake horsepower that was listed per the energy code requirements? So we've circled here, fan 1 is supposed to be a supply fan with a motor horsepower of 10 horsepower. The return fan is supposed to be 5 horsepower. Does that match what's actually in the building, or was something different done? Did something get changed? Does it still comply with the energy code? Again, that horsepower requirement is based on the total supply air CFM going through the system. There's a simple table in the codes that has a calculation method for how to find that. For energy recovery systems, making sure that they are in place where they are required and that they are functioning properly. Probably the most common energy recovery system that we see out there is the energy wheel. You also see full energy heat exchangers where you've got a cross-flow plate and frame heat exchanger, but the materials are such in that exchanger that it can also transmit moisture, so you get total energy recovery with a system like that. But the energy wheels are most common. But another place where you can see energy recovery systems is with a hot gas reheat coil. This should not be confused with a hot gas bypass system, which is set up a little differently. Um, the hot gas bypass system is not considered an energy recovery system, but the hot gas reheat coil system, such as this setup, is considered an energy recovery system because you're pulling heat that would otherwise be rejected by the condenser and sending it to a coil after the evaporator for reheat. Typically, you see these on systems designed specifically for humidity control, but you can see this as an option for rooftop units, and it is an energy recovery method. HVAC economizers, are they working properly? Do the dampers have full range of motion? Are the set points correct for the climate zone that you're in? All important considerations for economizing systems. So we do have a quick poll to get into before I turn it over to Ryan to cover electrical systems. So our first question is time-based domestic hot water circulation acceptable for control? Yes or no? And question number 2 is, which of the following are part of the mechanical inspection? Duct insulation R value, energy recovery, equipment physical size, damper air leakage, duct sealing, heat traps. Pick all of the correct answers there. Give it a few more seconds for replies to come in. Okay, it looks like about tapering off there. Share those results. Looks like most people got the first question correct. Time-based controls are not allowed. It must be a demand-based control, a flow sensor, occupancy sensor, depending on your system control type. And then for question number 2, which of the following are part of the mechanical inspection? All of those except for the physical size of the equipment are part of the mechanical inspection, at least as far as the energy code is concerned. So it looks like most people got that.
Yeah. Heat traps would also not be part of the mechanical. That's in the plumbing section. So a little bit of a hump there. So, but that definitely would be something that would be inspected for. So, all right. So as far as electrical, so we're going to touch a little bit on electrical. This is where a lot of time and effort beyond the mechanical is electrical, as far as time and effort for particularly the commissioning of these systems. So as part of the electrical systems inspection, looking at the controls, are they in place? Are all the proper components there, and metering? So as far as system controls, lighting system controls, this is all your occupancy sensing, your daylight harvesting, your which frequently is daylight responsive controls with full continuous dimming. So there is a whole lot to be commissioned here in the lighting system controls. And with this, so a lot of this is going to be leaning again on your, the inspection is predominantly going to be focused on are the controls present and installed, and then leaning on the commissioning segment as far as going through and verifying that the controls are working properly, because part of this is part of the commissioning process is not only making sure that they are present, but are they in the correct location? Are the indicator lights working? Is their coverage area set up properly? This would also be where your time delays, your sensitivities, and the like. So, This could be rather in depth. And similarly, all the system components, are they present and accounted for? So this is your occupancy sensors, your vacancy sensors, your daylight responsive controls, your timer functions for those spaces that are not covered by occupancy or occupant sensing devices, photo cells for exterior, your uh, programming components, because a lot of these daylight responsive controls and more even occupant sensing controls have separate programming devices, which you may have caught on a couple of slides earlier. There was that remote control for programming and reprogramming that functionality. So it may be such that as spaces change in use, that daylight responsive control may need to be adjusted for the light level that is required for that space. And it may even be commonly built in that individual fixtures have dimming functions built in, uh, where we're seeing that more and more in LED fixtures, where they can be programmed to adjust their output. So as the LEDs themselves degrade over time, they will slowly turn up their output to compensate for that degradation over time. A lot of this, as far as the inspection, are just verifying that all the components are present, and again, leaning on that commissioning document as far as, are they properly functioning. So electrical metering is also now required for R2 occupancies. So this is, again, similar to that list of what is considered as residential building occupancies. But there may be times where you have you are in a 4-story or taller building, or perhaps in the city of Chicago, 5 stories and taller. So you would be in a commercial building with residential occupancies. So you may have R2 occupancies in a commercial building. Each of those dwelling units does have to have some sort of individualized metering. So this could be any number of different things. From the right-hand side, where commonly you see the utility meter stack, and so everyone has their own individual meter and gets their own individual utility bill. But that's not necessarily required. There's nothing that requires that they be individually billed, but you do have to have individual metering, such that that enables the building owners to understand as far as differences in consumption across units. This can also be very useful for troubleshooting. So if all of a sudden that they see a particular dwelling unit with this may be for areas that have heat pumps with electric resistance backups. And so it may be such that a unit malfunctions, and all of a sudden you see a real big spike in electric consumption of a particular dwelling unit. And so the building engineer may know to go investigate what is causing that dramatic jump in use. So many different devices. There's a couple shown here as far as that goes, where it's consolidated into a single device. And some of these can a single device here could track as many as 30 or even possibly more dwelling units using a single metering device and a set of CTs. So that's a lot of electrical. So again, a lot of this is going to be focused on commissioning, that we'll talk about here in a little bit again. So moving on to our final inspection. So one of the aspects here for the final inspection, making sure that all the proper building controls and documentation is in place and available. And it also calls out that the commissioning has to have been conducted by this time. So as Sean noted earlier, one of the first phases of commissioning is going through and just checking all the systems and reporting what their present findings were. So this would be initial functional performance testing. You know, did all the dampers open and close like they were supposed to? And even if they didn't, that's fine. But that would be part of the documentation, is, you know, documenting, you know, that the damper didn't fully open and that there needs to be remedies made. So this would be, as you're getting to the end of the first phase of commissioning, this would be where the final final inspection would come in. Is you're after the first initial phase of the commissioning, and the remedies and punch list would be developed. So at this point, there should be a punch list of items that need to still be remedied, that would take place perhaps prior to or even after final inspection. So again, part of this is catching anything that may have been outstanding from previous inspections. So there may be certain aspects where something is called for in a prior inspection. Perhaps something in the electrical system, or maybe it's even just a heat trap as part of the mechanical system where some heat traps were missing. And so identifying that and saying, okay, you may continue with construction, but you need to get this the heat traps installed. So here again at final, going back and catching any of those items that would have gone on that punch list, and checking to verify that those have been taken care of before issuing that certificate of occupancy. One other aspect of this is, again, the documentation, and making sure that that is available and ready. One piece of this is the operating manuals. The code calls out that within 90 days of the certificate of occupancy, the owner is to receive the O&M documents. And part of that is also a listing of all the routine maintenance that is supposed to be done and where specifically in the O&M documentation those processes may be found. Understanding that it is not practical, because following a certificate of occupancy, that is kind of where the code official's job ends. So how we see this addressed in some municipalities is one of the pieces of documentation that has to be provided as part of this final inspection is a letter from the building owner that they understand that they are to be expecting to receive the O&M documentation and manuals along with that listing within 90 days of the certificate of occupancy being issued. So at least that has placed the building owner on notice that they should be expecting these documents. And by having that notice, in the event that those documents don't come through to the building owner, they know to go over to the project team and request those documents. So again, with this, commissioning has really become a big aspect at the forefront, because this captures a lot of the challenges and issues that we are finding with new construction. Inspectors are fairly equipped to inspect, things like the envelope and see, was air sealing done? We have two materials that came together. Is there a seal? That is highly visible. What is captured during commissioning of buildings is all the interactions between the different mechanical systems and verifying that they are the systems are operating as they were designed. because of all the interactions, it's not uncommon during commissioning to find issues where some interaction occurred, and so an air handler is not turning off even when it goes to unoccupied mode. So things like that could really come out in that commissioning process, and don't shortchange this process. Um, you know, it is likely commissioning that is leading to poor building performance and poor building operation for modern buildings. Uh, you know, I noted we don't build walls dramatically different over time. A CMU wall goes up the same now as it has in the past, but with more and more bells and whistles being added to systems to try to drive down that building performance, or drive down that building energy consumption, uh, more and more issues arise with that. So with that, I think we do have one more poll question here. So for our electrical and final inspections, lighting controls requiring inspection for the energy code includes which of the following? And you may choose more than one or choose all that apply. Occupancy sensors, daylight harvesting controls, light switches, daylighting controls, and time switches. Second question, when does the initial commissioning need to be completed by? Before the mechanical system inspection, before the electrical system inspection, or before the final inspection? Um, Again, do want to remind people, if you do have any questions that you may have, go ahead and feel free to use that Q&A button located towards the bottom of your screen. And if you do have questions or you do think of questions after today's session, again, go ahead and feel free to reach out to us, energycode@sedac.org. All right. For our lighting controls requiring inspection, occupancy sensors, yes. Daylight harvesting controls, yes. Light switches, not part of the energy code. Daylight controls, yes, and time switches. So uh, looks like most people did pick everything but light switches. So, and when does the initial commissioning need to be completed by? No later than the final inspection. So most everyone picked up on that. So that's very good. Um, so with that, not sure if we have any other questions that people may have out there. Uh, One thing I would ask is if you are, I realize today's session is regarding commercial buildings, uh, but if you do email us a question after today's session, uh, something that we would ask is if you are, if you do email us a question, that you do indicate if you are in a commercial building or a residential building. Because as I noted earlier, the energy code is broken into two kind of segments, commercial provisions and residential provisions. And so wanting to make sure that we get you an answer as quick as we can, and don't want to end up, if you have a high-rise residential building, we don't want to accidentally give you an answer based on the residential provisions unless it was it's a specific cross-reference back from the commercial provisions back to a residential provision. I have a question here, good question about the difference between an occupancy sensor and a vacancy sensor. The difference between those two, both are occupant sensing devices. The difference between these two are whether the switch will activate based on an automatic on signal, or if the occupant has to do something to cause the sensor to trigger on. So an occupancy sensor will automatically turn lights on and automatically turn them off. A vacancy sensor requires a user input in order to turn the lights on. So it's a manual on with an auto off function. Occupancy sensors, the code does call out several locations that an auto on is acceptable, either to 50% for many locations, and there's a few locations, things such as restrooms, corridors, stairwells, that are an auto on to full 100%. So many rooms do require occupant sensing devices that could either be occupant sensors or vacancy sensors.
Okay, I don't see any other questions coming in. Oh, here's one. How often should energy inspections happen throughout a build?
The code calls out the code calls out for commercial buildings 6 different times that energy inspections would occur. However, that may vary depending on jurisdiction by jurisdiction. In mentioned earlier, it's not uncommon for buildings to have 10 or 20 inspections. And so there may be different aspects of the energy code that are inspected during different ones. So the code calls out 6 specific inspections, but those may be broken up differently based on your particular municipality. So do check with your local jurisdiction as far as how they wish to handle the inspections.
And those inspections, just for reference, are the footing and foundation insulation inspection, the thermal envelope, plumbing systems, mechanical systems, electrical systems, and then the final building inspection. All right, well, we'd like to thank everyone for joining us today. Once again, if you do have questions for us, please reach out to us at energycode@sedac.org, and we will be glad to answer your questions. Thank you for joining us today. We hope you all have a wonderful afternoon.